NASA engineers have re-established communication with the Voyager 1 spacecraft, Earth's most distant emissary, after months of troubleshooting a glitch that had rendered the probe's transmissions unreadable.
Reports of extraterrestrial life and fears of an impending alien encounter have fueled public anxiety, particularly after NASA's Voyager 1 probe, launched in 1977, began transmitting confusing and seemingly corrupted data. The unexpected signals sent back by Voyager 1, originally designed to study Jupiter and Saturn, have left astronomers puzzled. Could this be more than a simple technical malfunction? Is it possible that Voyager 1 is conveying something we are unable to interpret? On December 12, 2023, Voyager 1, the oldest and most distant human-made spacecraft, experienced a troubling anomaly that sent shockwaves through NASA and the global scientific community. After more than 4 decades traveling through the solar system and into interstellar space, the probe suddenly began returning strange binary outputs, endless strings of ones and zeros that made no sense to engineers. Although NASA could still send commands to Voyager 1 and confirm that many of its systems were operational, the data it transmitted back was meaningless, signaling a serious failure. Losing reliable communication with the farthest object ever built by humanity would be a devastating blow to science. NASA's first response was to attempt a reset of Voyager 1's flight data system, but the effort failed. The spacecraft continued sending incoherent information. For months, engineers worked relentlessly, testing potential fixes through careful experimentation, yet progress remained slow. As time passed, concern intensified. Any prolonged disruption could permanently sever humanity's connection with this historic probe. Eventually, NASA scientists identified a possible workaround, restoring a measure of hope. Still, the unexplained nature of the malfunction sparked widespread speculation. Was this merely an aging system breaking down after decades in deep space, or could something more unsettling be responsible? Science fiction has long imagined scenarios in which alien civilizations interfere with human technology. Films such as Arrival, War of the Worlds, and Independence Day explore the idea of extraterrestrial contact posing an existential threat. Could Voyager 1's strange behavior hint at something similar? Viewing Voyager 1's journey through a science fiction lens is both captivating and unsettling. The spacecraft carries the famous golden record, a message in a bottle meant to represent Earth, complete with sounds, images, and greetings for any intelligent beings who might encounter it. Should an alien civilization discover Voyager 1, they would gain insight into humanity's culture, biology, and technology. Such a revelation could inspire curiosity or provoke danger. This possibility raises uncomfortable questions about the risks of sending our identity into the unknown reaches of space. Despite these speculative fears, the drive to explore remains fundamental to human progress. NASA's mission is not only to address profound questions, such as our origins and whether we are alone, but also to deliver tangible benefits to life on Earth. Space exploration has led to technological breakthroughs, strengthened international cooperation, and inspired generations of scientists and engineers. Programs like the International Space Station, involving multiple space agencies from around the world, and the Artemis Accords, signed by dozens of nations to support lunar exploration, highlight the global nature of this endeavor. Voyager 1's legacy is impossible to overstate. Over the course of its mission, it has transformed our understanding of the solar system. Among its most remarkable discoveries was revealing that Jupiter's moon Io is a geologically active world, filled with intense volcanic activity rather than being a lifeless body. Voyager 1 also delivered breathtaking images of Saturn, unveiling its rings in unprecedented detail. Observations of Titan, Saturn's largest moon, suggested the presence of liquid water, sparking hopes that life might exist beyond Earth. These discoveries, and many others, have laid the groundwork for future exploration and reshaped our understanding of how planetary systems function. The mystery surrounding Voyager 1's current malfunction is not without precedent. Other spacecraft have faced similar communication failures, highlighting the immense difficulty of maintaining contact with probes operating at extreme distances from Earth. A notable example occurred in June 2018, when NASA's Mars rover Opportunity fell silent after a massive dust storm engulfed the red planet. The storm blocked sunlight from reaching the rover's solar panels, cutting off its power supply and preventing communication with Earth. Spanning an area larger than the continent of Africa, the storm proved overwhelming. Launched in 2004, Opportunity had already far exceeded its expected mission lifespan and delivered groundbreaking discoveries, including evidence of minerals that form in the presence of water, strong indications that Mars may once have supported habitable conditions. Despite NASA's persistent efforts to re-establish contact, which included sending commands and even broadcasting music, the rover remained unresponsive for months. Its silence raised growing concerns about whether communication would ever be restored, serving as a stark reminder of the unforgiving and unpredictable nature of space exploration. Martian dust storms can last for weeks or even months, reaching heights of 20 to 30 kilometers and electrically charging the atmosphere, conditions especially dangerous for solar-powered rovers like Opportunity. Although the rover had survived previous storms, the 2018 event underscored the limits of technology in extreme environments. The stories of Opportunity, and more recently, Voyager 1, highlight the fragility of humanity's ventures into space. While these missions have produced extraordinary scientific breakthroughs, they also face enormous risks stemming from vast distances, harsh conditions, and aging technology. Yet these challenges often fuel innovation and deepen our fascination with the universe. As NASA worked to diagnose Voyager 1's failure, the broader implications of space exploration became increasingly clear. Beyond expanding scientific knowledge, such missions prompt profound questions about humanity's place in the cosmos. The possibility of extraterrestrial life, the chance that other civilizations might intercept our signals, and the inherent risks of exploring the unknown all add layers of intrigue to the story of spaceflight. Despite early fears surrounding Voyager 1's malfunction, its legacy remains secure. Whether or not the issue is fully resolved, the spacecraft has already succeeded in its mission to push the boundaries of human understanding and explore regions never before reached. Its achievements will continue to inspire future generations of scientists, engineers, and explorers. On February 13, 2019, NASA officially declared the end of the Opportunity mission. After sending more than 1,000 signals to the rover since August 2018 without receiving a response, the agency acknowledged that the mission had come to a close. Although Opportunity's journey had exceeded all expectations, many unanswered questions remained, questions that echo across space, given the vital roles that spacecraft like Opportunity and Voyager have played. The remarkable data they returned to Earth has fueled curiosity and wonder worldwide. Launched in 1977, Voyager 1 has been a trailblazer in space exploration, venturing farther than any other human-made object. After crossing the heliopause, the boundary where the Sun's influence gives way to the interstellar medium, Voyager 1 entered interstellar space, often described as the vast big empty between the stars. This immense region, largely devoid of matter, represents a frontier never before explored by humanity, where the stars themselves are the only landmarks. Although Voyager 2 was launched first, Voyager 1 overtook its twin on December 15, 1977, traveling more rapidly through the asteroid belt and ultimately becoming the farthest spacecraft from Earth, a distinction it holds to this day. Throughout its journey, Voyager 1 made a series of discoveries that transformed humanity's understanding of the solar system. Among its earliest findings were the discoveries of two previously unknown moons, Thebe and Métis, as well as the detection of a faint ring system around Jupiter. On March 4, 1979, Voyager 1 transmitted the first-ever images of Jupiter's rings, unveiling a phenomenon that had never been directly observed before. As the spacecraft approached the planet, it also captured unprecedented views of Jupiter's turbulent atmosphere, revealing a far more chaotic and dynamic environment than earlier missions had suggested. Voyager 1 reached its closest approach to Jupiter on March 5, 1979, passing within approximately 174,000 miles, 280,000 kilometers, of the planet. During this flyby, it obtained detailed images of Jupiter's major moons, including Amalthea, Io, Europa, Ganymede, and Callisto. The observations of Io were especially remarkable. The moon appeared as a vividly colored world marked by shades of orange, yellow, and brown, unlike anything previously seen. Most astonishing was the discovery of active volcanism. At least 8 erupting volcanoes were observed ejecting material into space. This revelation established Io as the most volcanically active body in the solar system and suggested that volcanic material from Io could be contributing sulfur and oxygen to Jupiter's atmosphere. After completing its exploration of Jupiter, Voyager 1 set its sights on Saturn. On April 9, 1979, the spacecraft performed its first trajectory correction to ensure a close encounter with the ringed planet. A second course adjustment on October 10, 1979, was necessary to avoid a potentially dangerous collision with Titan, Saturn's largest moon. These maneuvers prepared Voyager 1 for another series of groundbreaking discoveries. Voyager 1 arrived at Saturn in November 1979, where it revealed a remarkably complex ring system composed of hundreds of individual bands. It also discovered 5 new moons and identified previously unknown features, including Saturn's faint G-ring and mysterious spokes, temporary, wedge-shaped clouds of fine particles within the B-ring. The spacecraft also confirmed the presence of shepherd moons, small satellites that help maintain the structure of the rings through gravitational interactions. During its Saturn flyby, Voyager 1 captured detailed images of several of Saturn's moons, including Titan, Mimas, Enceladus, Tethys, Dione, and Rhea. These observations showed that many of these moons are composed largely of water ice, significantly advancing scientific understanding of icy bodies in the outer solar system. Titan, in particular, drew intense interest due to its dense atmosphere rich in nitrogen, methane, and complex organic compounds. These findings suggested that early chemical processes similar to those that may have occurred on Earth could be taking place on Titan, making it a compelling candidate in the search for extraterrestrial life. Following its planetary encounters, Voyager 1 entered a new phase of exploration. In 1989, the mission was officially renamed the Voyager Interstellar Mission, with January 1, 1990, marking the start of its extended objectives. The mission's focus shifted toward studying the outer boundaries of the Sun's influence and the transition into interstellar space. A major milestone was reached on February 17, 1998, when Voyager 1 surpassed Pioneer 10 to become the most distant human-made object from the Sun, at a distance of 69.4 astronomical units. On December 16, 2004, Voyager 1 crossed the termination shock, the region where the solar wind slows dramatically as it approaches interstellar space, at a distance of 94 Australian dollars. It then entered the heliosheath, the outermost layer of the heliosphere, where it continued collecting data on the interaction between solar and interstellar particles. Another historic moment occurred on August 25, 2012, when Voyager 1 officially exited the heliosphere and entered interstellar space. This transition was confirmed by a sharp rise in cosmic rays and a corresponding decline in particles originating from the Sun. Even in this uncharted region, Voyager 1 continued to transmit valuable data, offering scientists unprecedented insight into the composition and behavior of interstellar space. On September 5, 2017, NASA celebrated the 40th anniversary of the Voyager missions. Remarkably, Voyager 1 remained operational, transmitting data through NASA's Deep Space Network from 4 functioning instruments: the magnetometer, plasma wave experiment, low-energy charged particle detector, and cosmic ray telescope. Together, these instruments provide a continuous and unparalleled view of the interstellar environment. One of the most enduring symbols of the Voyager mission is the Voyager Golden Record, a 12-inch gold-plated copper disc created by a team led by astronomer Carl Sagan. Each Voyager spacecraft carries one of these records as a message to any intelligent civilization that might encounter it. The Golden Record contains greetings from world leaders, including U.S. President Jimmy Carter and UN Secretary-General Kurt Waldheim, along with music from diverse cultures, natural sounds, images of Earth, and spoken greetings in 55 languages. Together, these elements serve as a time capsule of humanity, offering a snapshot of life on Earth to the cosmos. In addition to its audio content, the Voyager Golden Record contains 115 carefully selected images that portray life on Earth. These images were chosen to reflect both the richness of human culture and the diversity of the natural world. They depict people from different ethnic backgrounds, scenes from everyday life, architecture, food, and landscapes, alongside scientific diagrams and charts. Images of animals, plants, and natural environments are included as well, many accompanied by annotations that explain concepts such as scale, time, mass, and chemical composition. Together, these visuals offer a structured yet deeply human portrait of our planet. Installed aboard the Voyager spacecraft as an ambitious and hopeful gesture, the Golden Record symbolizes humanity's longing to explore the cosmos and connect with intelligent life beyond Earth. It reflects an enduring optimism, the belief that one day another civilization might discover this message and learn who we are. The act of sending such a record into space, where it could remain for millions of years, highlights the profound scope of the Voyager mission. At the same time, it raises thoughtful questions about the wisdom of announcing our presence to the universe. On one hand, the recordings could serve as an introduction to Earth's biological diversity, cultural heritage, and shared values, potentially opening the door to future communication or cooperation with extraterrestrial beings. On the other hand, critics argue that broadcasting our existence carries risks. Humanity has no way of knowing what types of civilizations might encounter the records, or whether they would view us as allies or threats. Sending a message into the vast unknown without fully understanding the consequences is both exhilarating and unsettling. Yet this willingness to embrace uncertainty is the same force that has driven human exploration throughout history, from the depths of the oceans to the farthest reaches of space. Voyager 1, launched in 1977 to explore the outer limits of the solar system, has far exceeded its original mission goals. Along with its twin, Voyager 2, it has continued operating for decades beyond expectations. The successful restoration of Voyager 1 systems is especially remarkable given that the spacecraft has been active for nearly half a century and is now traveling through interstellar space. As it continues its journey, Voyager 1 carries not only scientific instruments but also a message of goodwill from Earth, intended for any intelligent beings that might one day encounter it. Beyond their scientific payloads, both Voyager probes carry golden records, phonograph discs designed to present the story of Earth through sound and imagery. These records were crafted with extraordinary care, using universal scientific principles rather than human language alone, so that any intelligent life form might interpret their meaning. Through these recordings, humanity extends a symbolic greeting to the cosmos, offering a glimpse of our world and our shared human experience across unimaginable distances. The golden records include natural sounds such as wind, thunder, and human heartbeats, creating an auditory sense of life on Earth. They also feature a wide range of music, from classical compositions to traditional folk songs, drawn from different cultures and historical periods. This collection highlights the emotional depth, creativity, and cultural diversity of humanity. In this sense, the records act as cultural ambassadors, carrying a fragment of Earth's identity into the universe rather than serving solely as scientific artifacts. Unlike ordinary vinyl records, the golden records are made of durable copper and coated in gold to ensure their survival in the harsh environment of space for potentially billions of years. Instructions for playing the records are etched onto their surfaces using mathematical symbols and scientific diagrams, including guidance on how to construct a stylus and playback system. One of the most ingenious features is a map showing the Sun's location relative to 14 pulsars, rapidly rotating stars that emit predictable radiation bursts and can serve as universal reference points. This diagram provides Earth with a cosmic address, an audacious attempt to guide any discoverer back to our home. However, this feature also sparked concern. While the pulsar map enables communication and potential contact, it could also attract unwanted attention. Some fear that revealing Earth's precise location might expose humanity to civilizations with unknown or hostile intentions. Despite these uncertainties, the primary purpose of the golden records remains clear: to promote goodwill, curiosity, and connection across the cosmos. They embody the dual nature of human exploration, the hope of reaching out to others, paired with the awareness of the risks that come with venturing into the unknown. In this way, the golden records stand as a powerful symbol of humanity's courage, curiosity, and enduring desire to understand and be understood in an immense and mysterious universe. At present, Voyager 2 is traveling roughly 12 billion kilometers from Earth. Although it faces its own operational challenges, it has remained more stable than Voyager 1, which has struggled with more serious communication issues. One of the most pressing concerns for Voyager 2 has been the risk of voltage fluctuations that could trigger power failures and potentially damage its scientific instruments. To address this, engineers developed a strategy that draws a small amount of energy from the spacecraft's radioisotope thermoelectric generator, RTG, a system that converts heat from radioactive decay into electrical power, ensuring that its instruments continue to function safely. Both Voyager probes now operate entirely autonomously, racing through space at nearly 56,000 kilometers per hour, far beyond any possibility of direct human intervention. Despite this immense distance, maintaining communication with them demands extremely precise calculations and constant adjustments from mission control. This intricate process resembles a carefully choreographed dance between the laws of physics and human ingenuity, reflecting our determination to explore and understand the universe, even when it requires transmitting commands across billions of kilometers. The communication failure experienced by Voyager 1 highlights just how difficult it is to keep decades-old technology functioning in the harsh environment of deep space. The spacecraft's flight data system, often described as its central nervous system, is critical to coordinating and managing all onboard operations. When engineers discovered a fault within this system, it posed a serious threat, not a minor glitch, but a problem capable of jeopardizing the entire mission. Months of careful analysis were required to trace the source of the malfunction. This situation underscores the extraordinary longevity and engineering brilliance of the Voyager probes. Designed more than 40 years ago, these spacecraft are still active, a testament to the foresight and craftsmanship of their creators. Investigators eventually identified the issue in Voyager 1 as a damaged memory chip, likely affected by aging hardware or bombardment from charged particles in deep space. Because repairing the chip remotely was impossible, engineers devised an inventive workaround. They separated the corrupted code and relocated its components to unused memory areas within the system. This complex solution required meticulous planning and flawless execution. Voyager 1 received its first corrective software update on April 18, 2024, given the enormous distance involved, resulting in a 30 billion mile round-trip signal delay. Scientists had to wait anxiously for confirmation. 2 days later, on April 20th, they received word that the patch had worked. While this brought great relief at NASA's control center, the job was not yet complete. The next phase involved reconstructing the missing sections of code so the spacecraft could resume transmitting critical scientific data to Earth. Throughout their long missions, the Voyager probes have endured countless obstacles, including intense cosmic radiation that degrades electronics, extreme temperature fluctuations that threaten sensitive instruments, and the hostile conditions beyond the heliosphere. At one point, Voyager 2 itself nearly fell silent, but engineers managed to restore communication, allowing the mission to continue. These experiences reveal both the limitations of early space technology and the astonishing achievements made possible by visionary engineering. That the Voyagers have traveled billions of kilometers and still send data home is a remarkable accomplishment. The successful recovery of Voyager 1 and the ongoing operation of Voyager 2 highlight the enduring legacy of the Voyager program. These missions have fundamentally reshaped our understanding of the solar system and interstellar space while delivering an unparalleled wealth of scientific data. The golden records carried aboard the spacecraft symbolize humanity's desire to communicate with other civilizations and share knowledge and culture, while also serving as a reminder of the risks involved in announcing our presence to the universe. In August 2023, Voyager 2 briefly appeared to be lost forever, but an unexpected reconnection once again demonstrated the resilience of the Voyager missions. For more than 4 decades, Voyager 1 and Voyager 2 have explored the outer reaches of our solar system and beyond. As their power supplies diminish, NASA has been forced to make difficult decisions, shutting down non-essential systems to conserve energy. Today, Voyager 2 operates with 5 of its original 10 instruments, while Voyager 1 continues with 4. To extend Voyager 1's lifespan, NASA has employed innovative conservation measures, including shutting off heaters and other secondary components to preserve essential systems such as the high-gain antenna. Despite these limitations, the spacecraft still carries critical instruments, most notably magnetometers, which have played a crucial role in studying the magnetic fields of the Sun and the outer planets. Even in their reduced state, the Voyager probes continue to expand humanity's knowledge, proving that careful engineering and perseverance can push exploration far beyond its original limits. In 2015, Voyager's instruments produced a major discovery when they revealed that solar winds can alter magnetic fields even beyond the heliopause, the boundary where the Sun's influence fades. Both Voyager spacecraft continue to rely on low-energy charged particle detectors, which were crucial in identifying the heliopause following a powerful solar eruption in 1993. In addition, the probe's hydrazine thrusters remain operational, allowing them to maintain proper orientation and regulate internal temperatures as they move through space. To survive the extreme conditions of deep space, the spacecraft are also equipped with micrometeoroid shields, which protect sensitive instruments from dust and debris. Another critical system still in use is the optical calibration target assembly. This system ensures the accuracy of scientific measurements by periodically aligning the probe's sensors with a reference target. Throughout their long journeys, these calibration procedures have been repeated many times, helping maintain the reliability and precision of the data they send back. Despite the shutdown of numerous instruments, some of which have been inactive for decades, these remaining systems have allowed Voyager 1 and Voyager 2 to continue delivering valuable insights into the nature of space. Power for both spacecraft is supplied by radioisotope thermoelectric generators, RTGs, which convert heat from the decay of plutonium-238 into electricity while also keeping the probes warm. This ingenious power source has allowed the missions to operate far beyond their original expectations. However, the output of these generators is slowly declining, and eventually they will no longer be able to support spacecraft operations, marking the end of these historic journeys. Even when the Voyager missions finally conclude, the vast amount of data they have collected will continue to shape our understanding of the universe. Their discoveries have deepened scientific knowledge of the outer planets, the heliopause, and interstellar space, influencing countless studies and theoretical models. Meanwhile, NASA engineers have worked tirelessly to overcome the challenges posed by aging hardware. After months of distorted transmissions that began in November, Voyager 1 successfully re-established clear communication on April 20th, sending back reliable data about its status and location. The moment was celebrated by NASA's official Voyager account with a lighthearted message, "Hello, it's me." The Voyager team has faced similar setbacks before, including a computer issue in 2022, and has consistently demonstrated remarkable problem-solving skill in keeping these aging spacecraft operational. While technical failures are expected after decades in space, the continued functionality of the Voyager probes is a testament to their resilient design and innovative engineering. NASA plans to operate at least one instrument on each spacecraft until around 2025. Even after scientific data collection ends, the probes may remain in contact with Earth via the Deep Space Network until approximately 2036, depending on remaining power levels. The idea that the Voyager spacecraft could continue communicating with Earth for years to come is both inspiring and bittersweet. These probes represent humanity's enduring curiosity and desire to explore the unknown, having traveled farther than any other human-made object, beyond the solar system and deep into interstellar space, still reporting on regions we are only beginning to understand. Some speculate that Voyager's recent anomaly could hint at something more mysterious, even suggesting extraterrestrial interference. Do you believe there is more to the issue than NASA has revealed? That's all the information we have for today. Share your thoughts in the comments below, and thank you for watching. Be sure to check out our other space-related videos while you're here.